Today is December 15th, 2011. We're going to continue with yesterday's lesson. We're going to be putting all the transformations and we're going to be transforming and stretching our sine function again. Okay? So yesterday we focused on what our variable a would do to this function. And we're going to put a couple rules along with it. Okay? So if a is a negative number, it's going to reflect on the x-axis. If a is a number that is greater than 1, it's going to stretch by that factor. So in other words, if a is a number like 3, 4, that means our sine wave is going to stretch by a factor of 3 or 4. If a is a number that is between 0 and less than 1, that'll be compressed by, I have to put that factor again. So if a is a half, this is too hard. If a is a half or 0.75, it's compressed by a factor of 0.75, compressed by a factor of a half. Whatever the a value is, that's also going to give us the amplitude of this wave. So when we talk about this, when a is a number greater than 1, I want you guys to think of it like waves in an ocean. If a number is greater than 1, the wave gets higher or higher, okay? If it's between 1 and 0, say this was the original, the waves get lower and lower, okay? That's what our compression and our stretch is for our sine wave. Now the other two variables we're going to talk about, which we did the other day, are going to be h and k. Oh, and one more thing. In our original one, when we have just f at x is equal to sine x, what's my a value? A value is 1. What's my h value? 0. And k? Good. Here's our h, and here's our k. Make sure you notice that, okay? That'll help you with your transformations. So our h deals with movements left and right. We'll deal with actually k first, just because it's more intuitive. When it's a positive number, you move in a positive direction. So our k, if k is equal to a positive number, we move up, which is a positive direction. If k is a negative, we move downwards, which is a negative direction. It's intuitive. If we have a positive number, we move in a positive direction. If we have a negative number, we move in a negative direction. Now with h, recall, I'm talking about all of h. So that includes the sign that's right in front of it. Okay? So if it is a positive 4, so if h is a positive number, we move left, okay, which is a negative direction. It's counterintuitive. And if h is a negative number, we move to the right, which is a positive direction. Okay, so we have our function. It's written as f at x is equal to negative 4 sine, bracket x minus 270, bracket plus 1. So what we're going to do is we're going to try to relate this to what each variable is equal to. We need to know what is our a, our h, and our k in this instance. So our a value is what?
4.
Negative 4. Good. Our h value? Yeah, you could say it is positive because we're moving in a positive direction. Or you could say it's 270, one of those two, okay? And our k value is 1, positive 1, okay? So those are all very important. We have to be able to define them by looking at this graph. And what I'm going to do, like usual, I'm going to start with the original one, and then I'm going to put all 3 transformations together on one graph. Exactly same. Okay. So our original function is f at x is equal to sine x. Now, on your quiz, I needed you guys to know the 5 key points. I hope you know them by now, which are 0, 0, 91, 180, 0, 270, negative 1, 360, 0. And then we continue that pattern.
So basically, you know.
Okay, so since we know one period of it, we can continue the cycle. It's an excellent way to describe it. Is we're going to continue this cycle here. Mine's not drawn so nicely. But here's our original one. Now, what we're going to do is I'm actually going to start. It's completely up to you if you guys want to start with your H, K, or A. If you do them correctly, you can do them technically in any order. For our sake, I'm going to start with the A, just because I know it's a little more complex. And then we're going to move everything from there. Okay? So our A is negative 4. So the very first thing that tells me is this function is going to be flipped. It's going to end up looking the opposite of what it was before. Okay? And now, because it's A, it's stretched by a factor of 4 in the opposite direction. So one way of figuring this out is taking all of our y coordinates and multiplying them by our A factor. Okay? So our very first coordinate is at negative 1. What is negative 1 times negative 4? Positive 4. So this y coordinate at 450 is now at positive 4. Okay? What about when we have 0 times negative 4? It's still at 0. So 360 is still 0. When we have 1 times negative 4, what will we get? Negative 4. Very good. 0 again is 0, and negative 1 again is positive 4. So we've done one period of this function. So I'm going to connect the dots here. And we're going to continue this. We know it's going to head downwards. I'm going to put all these. Oh, yeah. Yeah, it would be flipped from what it is. And we're going to continue this cycle. Ooh, that was a little off. All right, so we have just done one transformation. So what I'm going to show you of, this is technically only of the graph f at x is equal to negative 4 sine x. That's all that is a graph of, okay? That's only a graph of f at x is equal to negative 4 sine x. I haven't done either of the transformations yet. I haven't shifted this function left or right, nor have I shifted it up or down. In order to do that, I have to apply my h or my k. And in the order of what I give you the rules, we'll apply the k first. So the green one will be our next function. All I'm doing is I'm taking every major point that I've plotted on this graph, and I'm shifting it up 1, because k is equal to positive 1. So I take all of these points, and I shift them up 1 unit. So this is now goes up to 5. 0 now goes up to 1. Oh, that's not where 0 was. Sorry. Let's fix that. 0. Not sure why I drew it there. 0 goes up to positive 1. There you go. 4 goes up to negative 3. 0 goes up to 1 again. 4 goes up to 5. And we would continue that pattern. So if you take a look, it's the same shape as our red one. I'll do my best to mimic it. All that happened is it's been shifted up 1 unit along our graph here. So we've completed one cycle. It's still the same idea. We shift every major point up a unit. 0s go to 1, 4 goes to 5, 0 to 1, negative 4 goes to negative 3. So we're going to continue this graph. Turns, comes up, and goes back down. Whoops. So the green one is an f at x, and I'm just going to write it underneath so we have room. It's of negative 4. We have applied that. Sine x plus 1. So we've applied a plus 1 to this. I still haven't applied my h to it. So I'm just writing out what these would be as an equation, okay, so you can see each step. The final one we want to do is our h. Now h is negative 270. So which direction would I go? To the right, how far? 270. So this is dealing with our x-axis. So one way you can think of it, if I'm at negative 450, I'll put it in our calculator. We have negative 450. And I have to go to the right 270. I add 270. This will give me the new x value, which is negative 180. So when I'm at 5, my x value is 180. Oh, shoot, wrong color. Okay? So, with that being said, what is 360 plus 270? It's going to be 90, negative 90. So, remember, it was at 1 here. Our negative 90 is going to be at 1. All I really need to do is find out one period, and then I can continue the cycle. So I'm going to find out one period as we go along. At negative 270, I was at negative 3. What's negative 270 plus 270? 0. So I'm going to be at 0 and negative 3. Negative 180, we get the idea. It's going to be back at 1 again. Yeah, we do the mirror image of it. And then we come back up at 180. So if you look, I've completed one period of this function, and now I can continue this because I do need to see this all the way through. I didn't put a restriction on it. So when I get to 270 again, I'm at 1, 360s at negative 3, 450s at 1, so I continue this pattern. Go up. And then the same thing on the way down. 1, 360s at 3, and 1 again. So our blue wave is the final answer here. And our blue wave is going to represent f at x is equal to negative 4 sine x. Oh. Yeah. Highlight what's important. So, x minus 270 plus 1. That is our final graph there, the blue function. Question number 9 in your textbook reads, a Ferris wheel at the county fair or fall fair has a radius of 12 meters and rotates once every 60 seconds. At its lowest point, a rider is 2 meters above the ground. Another Ferris wheel at an amusement park has a radius of 15 meters, rotates once every 75 seconds. On this ride, the highest point a passenger reaches is 33 meters above the ground. So we're going to draw diagrams of these two Ferris wheels. We have our first Ferris wheel, which had a radius of 12 meters. We have our other Ferris wheel. 12. So our first Ferris wheel had a radius of 12 meters. The second Ferris wheel had a radius of 15 meters. Okay? These are quite big Ferris wheels, both of these. It says that the first one rotates every 60 seconds. So let's make the assumption that you start at the bottom of this Ferris wheel at 0. A full rotation, so going all the way around, takes 60 seconds. Okay? So let's try to break this into quarters. If I were to get to the top, how long would it take? Good, 30 seconds. And to get halfway there? 15 seconds. And halfway between the top and the bottom again? 45. Good. Very important to know. The other Ferris wheel has 0. This one takes 75 seconds to get around the circle. Okay? So, we got to figure out how long it would take it to go halfway. Great. 37.5 seconds to get to the top. How long would it take to get a quarter of the way there? 18.25. And then a quarter of the way back to the bottom again?
You just add that to 47.75. 55.75.
56? 56.25. Okay, so we've broken this into quarters, how long it takes both of these Ferris wheels to get around. We also need to know the highest and lowest points in order if we're going to graph this function. It said at its lowest point, the rider is 2 meters above the ground for our first Ferris wheel. So what that means is that this Ferris wheel here, lowest point is 2 meters. Okay? If it has a radius of 12 meters, the middle of the Ferris wheel is how high off the ground? 14 meters. Because the lowest point plus the radius will give us the middle of the Ferris wheel. So if we're at 14, how high is the highest point of this Ferris wheel? 20. Yes. 12 plus the 14. So, we'll go over again how I found that. They said the lowest point of this Ferris wheel was 2 meters above the ground. So this distance is 2 meters. We know that the radius of our circle was 12. So I take the 2 meters and I add the 12 meters of the radius. It tells me the middle of the Ferris wheel, which is actually quite important too when we go to graph this. So I have the middle of the Ferris wheel, which is 14 meters. And then the very highest point, the peak of the Ferris wheel, will be the 14 plus the radius, which is 12, gives me the 26 meters. Now in the other Ferris wheel, they've described it a little differently. They've told us that the highest point is actually 33 meters above the ground. Okay? If the radius is 15, and I need to find the middle of this, I'm going to be subtracting 33 subtracted by 15, 18? Yeah. Yes, very good. The middle point is 18 meters, and then the lowest point would be 18, subtract 15, which will be 3 meters above the ground. Our Ferris wheel here, what I want us to do is, for the sake of time, we're only going to graph the first one. Okay? So we're going to deal with only Ferris wheel number 1 in this question. We're going to graph it and then get its equation as part of your work. If you want to be challenged, you can do the second one. So this graph has a lowest point of 2, the Ferris wheel. It's going to be at least 0 because we know that's the ground. And we need to get up to a minimum of 26. So I'm going to make my graph because I know that above the ground, here's my x-axis and my y. I'm going to make the x-axis my ground. I'm going to make this go up by 3s, okay? So we go 6, 12, 18. I think I jumped one. Oh, it's too high. 24 and 30. Now on my x-axis, I need to include, in the question it tells us we want to include maybe 2 cycles of this. So if we need 2 cycles of this function and it takes 60 seconds, that means I need this function to go to at least 120 seconds in order to graph it. Because 2 cycles, 60 plus 60 would equal 120. So, because I needed at least 2 cycles, I decided to go up by 15s. I go from 0 to 150. Now, in the question, let's say it tells us that you start this Ferris wheel at the bottom. Okay? So apparently you get onto the Ferris wheel at the bottom, which makes sense, 2 meters, looking around 6 feet to get on it. So this Ferris wheel starts at the bottom, which is 2 meters above the ground. So that would be roughly here. At 15 seconds, we're at 14 meters. 14 meters is going to be just a little higher than this, below that line. At 30 seconds, what's our highest point?
26.
26. So we get up to about, it's going up by 3s. We get up to there. Then we repeat the pattern. It comes back down. reaches its low point, goes back up, reaches the high point, goes back down, reaches the low point, and we decided to keep going, let's say. For some reason, this Ferris wheel, after 150 seconds, stops, and you end up at the top, and you can't get off.
You're dead.
So,
There's a bunch of
if
questions.
we were to graph this function,
Does anyone have white out?
it looks like this, our function, okay? Now, I need to make sense of this function. I need an equation of the axis, and we can look at that really quickly. Equation of the axis is the middle of this. We already know it's at what? Close. Equation of the axis. Where was the middle of this Ferris wheel?
Oh, 14, yeah.
14 meters. Our peak was 26. Lowest point, the trough was 2. Okay? Amplitude. Amplitude is equal to what in this question? Radius. Good. It's equal to the radius, which is 12. So now that I have my amplitude, okay, I gotta make sense of this in our actual function of a sine wave. F at x is equal to a sine x minus h plus k. Now remember I told you your a value is actually equal to your amplitude. Okay? So the amplitude of this question, our a value, is going to be 12. Our a will be equal to 12 in this question. Okay? Now, so the one problem is I didn't talk to you guys about horizontal compressions. This has technically been horizontally compressed. But don't worry about it right now. What I want us to focus on is from our normal wave, what that transformation would have been. Now remember, our normal wave, the equation of the axis is at 0. Where's our equation of the axis? 14. So our k value is where the equation of the axis is. It's actually positive 14. The other thing is that normally we're at the equation of the axis at 0. How far over has this gone in terms of an h shift?
15.
It's gone 15 to the right. So if it's gone 15 to the right, our h is at, we'll say it's negative 15. So if we're going to put this now, please note that I did not address, this isn't technically the right equation, but for the answer of this, we have 12 x minus 15. Oh, I got to draw a sign in there.
Because it's going to move over. No, it has.
Sine.
Because the original one, the sine x, is in the middle. So they're just basing it off that.
So in terms of our question, I changed this a little. Okay, h is 15, but when we plug it in, it becomes negative 15. That is technically right, because we did go 15 degrees to the right. Okay? Because normally this point is down here. It's the middle of the graph, and it goes like that. The middle of the graph has been shifted over 15 degrees. Okay? Now, this equation does not address the horizontal compression. Don't worry about that. For what we're doing, this is what I need you to know. Okay?